in a way that everyone can understand. How does Holochain work, and why is it much more efficient than blockchain? In Holochain, system security comes from everyone agreeing to follow certain rules before they can use an application. The system then uses both technology and community oversight to make sure these rules are kept. Unlike blockchain, where there's just one shared chain, Holochain allows for unlimited number of individual chains that uses the technology. Every participant or agent in Holochain has a personal chain called the source chain, which they operate on their own device. The design of Holochain is streamlined, allowing it to function smoothly even on basic home computers. In Holochain, each application forms its own distinct network. While these applications can interact with each other, such connections are made only if necessary. To access an application, users must agree to its specific rules right from the beginning. The set of rules for each application is encapsulated in what is called the DNA. Each application's DNA is unique and determined by the app developer, much like how each living organism has its own DNA that dictates its characteristics. When a user agrees to these rules, they initiate their personal chain within the application by creating a first entry linked to this DNA. Following this, every action they take, such as sending messages or making transactions, is sequentially added to their chain, akin to the process in blockchain. However, unlike blockchain, which utilizes a single shared chain, Holochain operates differently. Each user maintains an individual chain, and this personal chain functions solely on their own device, not publicly. This approach lessens the network's load since each user brines their own resources to the network, enhancing the system's ability to scale as more users join. The establishment of DNA as the initial link signifies that all user actions will adhere to the application's DNA, essentially the set of rules defined for the application. Thus, the first record in each user's chain encapsulates the governing principles, the DNA, of that particular application. This commitment to follow the rules isn't just an initial promise that can be easily broken later. While theoretically, one could contravene these protocols, but due to the technical nature of Holochain, practically it's nearly impossible. Once data is recorded on your chain, it becomes unchangeable, immutable, unless you alter every single entry that came before it. Achieving this would require significant technical expertise and computational resources. Even if a user possesses such capabilities and attempts to commit fraud by altering the initial link, the DNA, or any subsequent ones, this risk is mitigated by the community oversight previously mentioned. In each Holochain application, every entry in a user's chain is turned into a hash code, and these codes are essential for checking each user's data for accuracy. Everyone connected to the network has access to these hash codes, such as those for the DNA. These hash codes are stored in a distributed network called Distributed Hash Table, DHT, which we'll discuss more later. For security, it's only necessary for a random group of users to compare the hash codes against the original DNA hash to confirm they match. Unlike blockchain, this process doesn't need the agreement of more than half of the users in the network. The analysis reveals that in a Holochain application, if half of the users are dishonest, only 7 trustworthy users are needed to ensure 99% security of the system. Even if 90% of users are dishonest, requiring only 43 honest users is sufficient for maintaining security. Adding more honest users beyond this point doesn't further secure the system. This indicates that blockchain's design, which necessitates a consensus of over 51% to maintain security, leads to scalability issues. In contrast, Holochain's more efficient design means that as few as 7 honest users can validate discrepancies between fraudulent hashes and the original, thereby securing the network. Moreover, using the gossip protocol, this information spreads across the entire network. Holochain compares this process to how a few cells in a living organism can detect a virus and initiate an immune response. Drawing inspiration from natural systems, Holochain ensures that any alteration a user makes to the initial entry, the DNA, or any subsequent part of their chain alters the hash. This alteration makes any tampered versions immediately noticeable. Upon detection, this triggers a significant response throughout the network, safeguarding the integrity of the system. Another aspect of Holochain's efficiency is the use of hashes rather than the data itself, which are shared within a distributed hash table. table. In this well-thought-out system, each user stores their own data privately on their device, and only the data's hash, a much lighter and unique identifier akin to a fingerprint, is made public. This ensures that only the necessary information, the hash table, is stored by everyone, allowing for security checks without the heavy data load. This contrasts with blockchain systems, where everyone carries the full weight of all users' data, significantly burdening the network. Imagine there's a gambling app on the Ethereum network that you don't use, but you still have to store its data on your device. This situation leads to a very cumbersome and overloaded system. Okay, everything is perfect, but one remaining issue in Holochain's system is accessing your data when you're not online. This is addressed by encrypting your data and distributing it among several users, ensuring it remains accessible even when you're offline. The distribution of your data among users can be tailored based on the data's importance and accessibility requirements. This flexible approach ensures that not all situations are treated the same, preventing undue strain on the system. Additionally, as the responsibility for data storage is shared across users, the system efficiently balances the load. Unlike in blockchain, where more users can lead to slower performance, in Holochain, the system's capacity actually improves as more users join, thanks to this shared load mechanism. In summary, Holochain addresses numerous challenges through its innovative design, to one that prioritizes the agent. Holochain can be considered the actual fulfillment of Satoshi's original vision, which started with blockchain but fell short of realizing the ultimate dream, Web3.